Okay, so we've got a stone that was dropped off a cliff. So let's draw a little cliff here. Okay, so we've got a cliff, and then we have a little person here. Be careful, don't fall off the cliff. And let's say he has a lichen-filled rock, and so he goes down. Boom, 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 drops it, and splat. Okay, so what it's saying here is that it hit the ground with a speed of 96 feet per second. So that's all we know, that the speed when it hits the ground is 96 feet per second. And then we want to know, well, what's the height of the cliff? Okay. So, let's write down what information we know. Now, since we are dropping the stone, well, we know for sure what the acceleration is. We know the acceleration is a negative 32 because of gravity. So, and this is in feet per second squared. So I don't really need that, but I just wanted to write it down. Okay, so that we know for sure. Okay, so acceleration is negative 32. All right, so since the question is about the height, well, we need to find the function for the height. So to find the function for the height, well, we first need to find the velocity. Now, the velocity is the antiderivative of the acceleration, which would be negative 32t, and then plus some constant c. Well, what is the constant c? Well, we need to have some information about velocity so that we can find what c is. So what do we know about velocity? So what do we know about velocity? Well, do we have the usual information that you have is that you have some information about the velocity, the initial velocity. So you ask yourself, okay, well, what's the initial velocity? How fast is the stone going right in the beginning? Well, it doesn't tell us, right? It's not 96 because that's the velocity at the end, and you can't use that because you don't know how much time has passed. And since he dropped the ball, the stone. Okay, so, but you do know that he dropped. Dropped. Not through drop. That means that the initial velocity is going to have to be 0, right? Okay, so then that means that the velocity is equal to 0 when t is equal to 0, which basically tells us that c is going to equal to 0. So that means that the velocity function is simply negative 32t, and that's it, just negative 32t. Okay, and then from this I need to go one step further to find the position or the height function. And the position is the antiderivative of the velocity, which is negative 16t squared. Now, where did the negative 16 come from? Well, remember, you add 1 to the exponent, divide by that same number. So 32 divided by 2 is 16. And then plus some constant. I'm going to call it d, not c, because c is up here. Okay. So then we go, what information do we have about the position? Well, we don't have the height because that's what we're looking for. That's the question. And the initial, so what we're looking for is the height of the ball, which is basically, it's basically asking me for the position when t is equal to 0. Or in other words, so I'll say aka, another way of saying that in this case is it's asking me what d is equal to. But how could I possibly find d if I don't have this information? Well, let's take a look at what we do have. The only information that we have is that the velocity when it hits the ground is 96 feet per second. So what can I use that for? Well, if I know the velocity is 96 feet per second down here, then if I plug it into the velocity formula, let's just plug it in and then talk about what that means. If I plug that into the velocity, so 96 is equal to negative 32t. I just plugged 96 into the velocity. What this is saying is that t is equal to 96 over negative 32. Okay. Now, small little detail actually. The speed is 96. Remember, the speed is the absolute value of the velocity, but the actual velocity itself has to be negative because it's going downwards. So that's a small little tidbit that I forgot, but that's okay. Small mistake there. Now t is equal to 96 divided by 32. That's going to be equal to 3, and the units are 3 seconds. Now it's really important to understand what is the interpretation of this time. What is that? So 3 seconds, that's how much, if t equals 0 is up here, well, t equals 3, that's when it's down here. So this is the time t is equal to 3. That's the time that it takes to hit the ground. Okay, so at the ground though, well, how can you use this information with the position function? How can that help you? Well, when t is equal to 3, what do you know about the position? S is going to equal to, what's the position down here? Well, it's 0, of course. So see, this is your point. This is basically telling you, if you put this together, this is saying that S of 3 is equal to 0. And this is your information about the position that you can use to find what D is. Okay. So that's our battle plan. So I plug in 3 for t and 0 for s. So 0 is equal to negative 16 times 3 squared plus d. Okay, so that means that d is equal to 16 times 9, which is equal to 144. And this is in feet. And that's it. So this is what the question was asking for. How high is the cliff? Because 144, when t is equal to 0, the height is 144. And so that's it.